All right, so basically in this time, I'm going to finish off the discussion to the sample exam 2 for specialist math. So remember these sample questions, I tended to demonstrate how new aspect of 3 and 4 specialist math may be examined in written exam 2. They do not constitute a full examination paper. So let's have a look at the multi-choice question section. So the first question, consider the following statement. For all integers n, if n squared is even, then n is even. So which one of the following is the contrapositive of this statement? Basically, if we have an original statement, P implies to Q. The contrapositive is just Q dash implies P dash. So the negation, if n squared is even, that would be n squared is odd. This would be my P dash. And then n is even, that would be n is odd, okay? So this would be my Q dash. So rewriting that in a reversed order, n is odd if then n squared is odd. Remember, the predicate or the condition or the scope of this statement is for all integers n. So I'm going to say it's still the same for all integers n. If n is odd, then n squared is odd. So I would say option D is the correct answer, okay? Right, next question. We have a pseudocode here, which is the new stuff to post method and special. Now the procedure below has been written in pseudocode. We have some integer n, we have some integer f, t1 and t2 representing the first and the second term. So firstly, f is 0, t1 is set to 2, t2 is set to 3, and n is set to 3. That means we have 3 iterations, because the whole process will be repeated by 3 times. And f is simply t1 plus 2 times t2. So your next calculation is to define or store t2 to f. So f is just an intermediate stage. I would say, okay, basically just say t1 plus 2 times t2 is assigned to the next t2. So the first step, t1 is 2 plus 2 times 3. That's your next t2, which equals to 8. Now, we haven't set other values for t1, so I will remain the same value for the letter or the term t1. Now, the next step, n equals to 1, n equals to 2. So t1 plus the previous t2 gives the next t2. So I'm still using 2 plus 2 times, but this time 2 times 8. That gives me second t2. So I'm going to get, I suppose, 18, okay? Finally, when n equals to 3, t1 plus 2 times the previous t2 gives the next t2, okay? So 2, still the same t1, plus 2 times the previous t2, 18. This will be 2 plus 36, which will be 38. Therefore, option C is the intended answer. All right, number 3, vector equations of the plane. So let's say we have this line L1 represented by R1, and this is L2. Remember, the direction of the lines are determined by their direction vectors. So I should have D1 and D2 as my vector direction equations, okay? Actually, this is my D1, okay? This is my D2. How do I find the perpendicular vector to both lines? That means I need to take the cross product, okay? So to get the n, the normal vector, I'm going to use, let's say, D1 cross multiply D2. And a proper setup for this cross multiplying is the determinant, 3 by 3 determinant, ijk. So D1, we have 1, 2, minus 1, 3 components here. And at D2, we have 2, 1, minus 1, okay? So skimming through all the available options, I would say, which one is the best choice? Option E, okay? Notice that it is also possible to switch this row and this row, but we don't have another option like that amongst the 5 available ones. So I can only choose E. Okay, question 4. 2 points with coordinate 5, minus 6, 4, and minus 3, minus 1, minus 10. So this is point A, this is point B. Basically, I'm looking at the lines through these 2 points. So firstly, I'm going to find the vector AB to represent my direction vector. This is D. D is going to be OB subtract OA, okay? Difference between the end point and the start point. So I'm going to say minus 3, minus 1, minus 10, subtract 5, minus 6, 4. And I'm getting minus 8 plus 5 and minus 14, okay? And also your reference point here should be A, or you could use B, but let's see if we have such an option. Let's stick with A first, left to the right, okay? And A is going to be 5, negative 6, 4. So remember the equation of any straight line in the 3D space is just R equals to A plus any constant T, any real number, because it's extending to both sides, okay? Can be 0, can be positive, can be negative. So T times D. T is any real number. So I'm going to say this is 5, negative 6, 4, plus T times negative 8 plus 5 minus 14, okay? Which means I'm going to use, which one is a suitable option? Well, if we had 5 minus 6, 4, but this one has the incorrect, this one has an incorrect option, okay. Right, and this one, start point is not correct. This bit is correct, but incorrect direction vector. So I only have A and E, but option E has the incorrect direction vector. It's not minus 8 plus 5 minus 14. So I'm trying another version. R equals 2. If I start with B here, I'm actually using minus D, okay? So this is minus D here. So I could also write it as vector B subtract T times D, which means I'm going to use minus 3 and minus 1, minus 10. Subtract T multiplied by my negative 8, 5, minus 14, okay? This also works, okay? Just in the other direction, but it's eventually extending to both sides. So I'm going to choose option A, okay? That's it. All right, now the plane is perpendicular to the vector n and it passes through the points 3, 2, minus 4. We just apply the formula here. R minus the reference point's position vector multiplied by n equals to 0. Or we can just directly use n1x plus n2y plus n3z equals to some k, okay? So now what I'm looking for is n1, n2, n3. So this would be x, 1x minus y plus 3z equals to k. Remember, we can substitute the point into the equation of the plane and find the constant k here. So 3 minus 2 minus 12 equals to k. So my k value is going to be, let's say, minus 11. So I'm going to get x minus y plus 3z equals to minus 11, okay? And if I scan through all the options, even though we have these correct combinations of the normal components, this is not negative 11. So instead, I could multiply both sides by -1 to get minus x plus y minus 3z equals to 11. So option B is actually the correct answer. Just need to multiply everything by -1 in your derived version, okay? All right. Now, this question is a very interesting one. So we want to find the shortest distance between the planes given by 5x minus 4y minus 12z and minus 15x plus 12y plus 36z equals to 20. Okay, so for consistency, best approach is to convert both equations in a similar form. What that means is, okay, now I noticed in the second equation it's minus 15, 12, and 36. I'm going to divide everything by -3. So I should get 5x minus 4y minus 12z equals to minus 20 over 3. So this is very important here, because first we have the first three letters exactly the same. That means we have two parallel planes. Okay, now this diagram here is not exactly to the scale, so I'm just using that as an indication to illustrate what's happening here. Well, if you notice, this is a positive 10. It's actually, let's say, away from the origin, okay? In a positive, tilted positive direction, and negative 20 over 3 is in the tilted negative direction, okay? So it's like this is the first plane, pi 1, okay? And this is the second plane, pi 2. Pi 2 to pi 1, okay? So now, if I'm looking at the relative distance between the first plane and the origin, there is a formula. Basically, we know this constant here is k, this constant, let's say k1, okay? And this constant here is k2, okay? The signed distance from a plane to the origin, relative to the origin, can be calculated by k divided by the magnitude of the normal vector, which is n1 squared plus n2 squared plus n3 squared, okay? So now, if I figure out the first distance, d1 here, d1 is going to be 10 over square root of 5 squared plus 4 squared plus 12 squared. I suppose this is 10 over root 185. And also, using the same logic here, this is d2. d2, remember, it's a signed distance, okay? It's going to be minus 20 over 3 divided by the square root of 5 plus 4 both squared plus 12 squared. This means it minus 20 over 3 times root 185, okay? So actually, we are not taking the difference of the absolute distances. We are making both parts positive and add them up, okay? From left to the right, for example. So we are adding up these two physical distances. So the final result should be 10 over root 185 plus 20 over 3 root 185, because I'm taking the absolute value of the second calculation here. This is a total distance. So I'm going to get, let's say, 20 over, actually 30, bear with me, 30 over 3 root 185 plus 20 over 3 root 185. So the answer should be 50 over 3 root 185, okay? All right, so if we have this option, that would be D, okay? So a couple of things. Draw a diagram to best understand, to best comprehend the scenario here. It's the relative signed distance from a plane to the origin, and the other plane is parallel to the first plane. So I'm drawing another plane, represent its distance. from the plane to the origin, but it's in the negative direction. Notice the negative sign here, okay? This question is very tricky. Finally, remember, you have a formula to use. For distance from the point to the plane, just apply, the point is origin, just apply k over the magnitude of the normal vector. Alrighty, question 7. The time taken by a machine to make electronic components varies normally with a mean of 20 seconds and a standard deviation of 2 seconds. Okay, after the machine is serviced, it is believed that the mean time taken has been reduced to 18.5 seconds with the standard deviation remaining the same. A statistical test is proposed to check whether there is any evidence of a 1.5 second reduction in the mean time taken to make components. The test statistic will be the mean time taken to make a random sample of 16. Okay, very long paragraph, but now what I want to extract is n equals to 16. And we are talking about the normal random variable x. Well, let's say, I suppose this is 20, okay? All right, and this will be 2 squared. This is the standard deviation squared, that's the variance. So now, the sample mean distribution for this hypothesis testing will be 22 squared over 16, okay? Now it's saying the type 1 error for the test will be alpha equals to 5% with the critical sample mean of 19.2 seconds. So I'm drawing a relatively longer x-axis. Actually, this is x bar, okay? So firstly, suppose our actual mean is 20, the population mean. Then I'm drawing a normal curve like this. All right. And what does it mean by alpha equals to 5%? That means if the test is one-sided, you are looking at the left tail, okay? So this left tail here, let's say this is 19.2. And this area here, let me just use a color, yellow. This is going to be 0.05. And what does it mean by type 2 error? Well, in this circumstance, if the actual is instead of 20, if the mean was actual mean was 18.5, then the whole curve of the x bar is shifted to the left, like this. Once it has been shifted to the left, the actual mean value is 18.5, okay? But the standard deviation remains the same. That means the shape or the spread of the curve is the same. And you're calculating the area shaded in red on the diagram. This is called a type 2 error, okay? Type 1 error is just your level of significance. Type 2 error is the other side under the new curve, all right? So this is beta equals to something. I don't know. I need to calculate that, okay? And this is alpha. So now, remember, our standard deviation for the x bar is the same, which means standard deviation x bar, as we talked about before, is just 2/4, which is half, okay? All right, how do I calculate the beta? I'm saying probability x bar 2, let's say this is x bar 2, this is x bar 1, okay, is greater than or equal to 19.2. Given that mu equals to 18.5 and sigma x bar equals to 1/2, okay? So now I'm going to use my norm CDF command on the CAS calculator and figure that out. Here's the calculator. Insert a calculator and probability menu 5, and we calculate 2. The lower bound is 19.2. Upper bound, let's say infinity, because The right tail never ends. Mu value is 18.5 and the standard deviation is 1/2. So I suppose this probability is closest to 0.0807. Okay, so let's go back. It's roughly 8%, okay? So the intended answer is option A. Of course, from an exam strategy point of view, we could also just look at the diagram we sketched. And okay, so the yellow part is roughly 5%. It will be insane to choose any value greater than, let's say, 20%, okay? Because that would be too large for this just a small tail, all right? So we can actually guess, okay, these four values are just too big, ridiculous. Then we can just guess option A is the most reasonable answer, okay? But I just used the calculator to double check, okay, if the answer makes sense. Should we use the all correct procedure to calculate the type 2 error probability? So you will need to use the similar procedure when you are determining the probability of committing a type 2 error. Basically, just draw two graphs, same shape with different mean, but they are sharing the same critical value, okay? It's always the other side. Okay, now let's have a look at the extended response questions. So, first one. Question 1 express this set z absolute value equals to z absolute value minus 2c pi over 4 in the form y equals to ax plus b, where a comma b are real numbers. Well, this is actually calculating the perpendicular bisector between 2 points, which is 0 plus 0i and 2c pi over 4. So what I'm writing here is, okay, z absolute value equals to z minus, for example, 2c pi over 4, I would say is root 2 plus root 2i, okay? Because when you just draw a diagram, the length here is 2 and the angle here is pi over 4, which means your horizontal component is root 2, vertical component is root 2, and this is where your complex number will be placed at. All right. Now the important thing is I'm going to say z equals to x plus yi. It's a variable containing two complex variable containing two real variables, x and y. So x plus yi minus root 2 plus root 2i, okay? Well, preferably you can use a by-hand calculation here to demonstrate how good you are with the mathematics, but now I'm going to use a calculator approach. So basically, insert another calculator page, and what I'm doing here is solve button. Absolute value z equals to absolute value z minus, let's say 2e I times pi over 4. This is the Euler form or the polar form of a complex number, comma y. Don't forget you need to substitute z equals to x plus yi. X plus y, missed an equal sign here, okay? Right, so I'll just put an I here. All right, so this is your Cartesian equation of the perpendicular bisector between 2 points, 0, 0, and root 2, okay? Root 2 minus x. Just write down that as your answer. And with the substitution and the sum up expansion, you successfully demonstrated your substitution or sum up methodology, all right? Of course, you can also use the midpoint approach and the perpendicular gradient approach. Solve for y. Let's say expand and solve for y. Y equals to minus x plus square root of 2, okay? And you should know that root 2 is roughly 1.414, etc., okay? Slightly below 1.5. And then the next part, on the icon diagram below, sketch and label A equals to Z defined by Z times Z conjugate equals to 4, which means this is a circle because Z times Z bar equals to 4, then X plus YI times X minus YI equals to 4, which means X squared plus Y squared equals to 4. Okay, radius is 2 because 4 is 2 squared, all right? So, well, if you have a pair of compasses, you can use a pair of compasses to sketch that circle perfectly. But if you don't have a compass, well, just try your best. So what I'm doing here is I'm using my magic pen. All right. You can see initially it was terrible, but eventually it becomes a nice circle. But I try your best, okay? And I label it. This is A equals to Z. Z times Z bar equals to 4. Z is any complex number, all right? Probably put it up a little bit down. And then think about the geometric representation of the line B here. Even though we obtained equation in the previous part. Okay, now let me just mark this point as 0 plus 0i, which is 0, 0. And this point is root 2 plus root 2i, okay? So basically, I'm looking at the perpendicular bisector between these 2 points, or the line segment between these 2 points. What I'm also using is a physical ruler here, okay? Don't be afraid to use a physical ruler. It draws perfect lines, and make sure your tip of the pen is closely aligned to the edge of the ruler. So what I'm trying is, okay, I know this is a 45-degree angle. So I'm going to put my ruler here and draw a very nice straight line, okay? Like this, right? So this will be my, for example, second set. Okay, so this is my B equals to Z, absolute Z equals to Z minus root 2 plus root 2i, close the absolute value. Z is any complex number, all right? And finally, don't forget to label the axis intercept to the upper B. I suppose you mark it clearly here. This. Okay. Right. Next part. Oh boy. Regions over complex plane are creeping in again back into the latest study design. So, yep, shading regions. So now, Z times Z bar is less than or equal to 4. That means everything within the circle, including the circumference itself, okay? And real Z plus imaginary Z greater than or equal to root 2. That means X plus Y is greater than or equal to root 2. So Y is greater than or equal to minus X plus root 2. Well, with the equal sign there, it only represents a straight line. But now you have Y is greater than or equal to that straight line. That means anything above this line. So if I intersect this region and this region, only this bit in the middle, which is a segment, will be our final feasible region. So I'm going to, use some nice color to shading whatever I need to shading. It's just this nice chunk of segment, okay? All right, so it's shaded on the previous part. And we want to find the area of the shaded region. Remember, now, if you have the physical official VCAA formula sheet, The area of segment formula is on this latest formula sheet. So you need to apply that successfully. Okay, so I know this is a segment. So I'm going to say a segment is equal to half r squared bracket theta minus sine theta. I know the radius is basically 2 because this segment is along the circle with the radius 2. But now what is my theta here? Well, if you drew both parts, B and C, very accurately, you should be identifying what's happening here. So you can see this is the first intersection here. If you just join, let me just use a pencil. You see my pencil mark here. So now I'm actually filling in the sector, okay? Sector. This sector contains that segment. We use that sector to determine the angle. Well, do some basic accounting here. 1, 2, 3, 4, 5, 6. So each 90 degrees quadrant is divided into 6 equal pieces. So each piece is just 15 degrees. So now this is 1 piece, 2 piece, 3 piece, 4 piece, 5 piece, 6 piece, 7 piece, 8 piece. 8 times 15, that's it. Okay, so let's write down theta value. Theta equals to 8 times 15 degrees, which is 120 degrees. But remember, we are using a radian measure to calculate that area, which is 2 pi over 3. And then I'm going to say half times 2 squared times 2 pi over 3 minus sine 2 pi over 3, okay? And this will be 2 times 2 pi over 3 minus root 3 over 2. So the answer is 4 pi over 3 subtract root 3. Or equivalent answer is 4 pi minus 3 root 3, everything on 3, okay? Units squared, okay? A very typical problem. Geometric problem always embedded with a complex number question in exam 2 in the past 10 to 15 years, if you look back at the past exams. Very common and familiar question. So make sure you use the correct angle subtended by the segment. And finally, the elements of z times z bar less than or equal to 4 intersecting the other line provides 2 of the cube roots of w. 2 of the cube roots of w. That means, okay, the intersections we have z1 and z2. z1 to the power of 3 equals to w, or z2 to the power of 3 equals to w. So what are z1 and z2? We want all 3 cube roots of w. So we look back at this diagram above. This diagram before told us, yep, this is, let's say this is z2 and this is z1. Well, don't forget each single sector subsection is 15 degrees, which is pi over 12. And it's all along the radius 2 circle. I'm going to say this is 2 cis minus pi over 12. Make sense? And z2 here is 2 cis, for example, 7 pi over 12. Okay, so we know this is like a nice application of De Morgan's theorem. It has to be dividing the whole circle of radius 2 in 3 equal pieces, which means the difference of 2 angles will be 2 pi over 3, okay? So going back to this part, the first cube root, z1 is 2 cis minus pi over 12. z2 is going to be 2 cis 7 pi over 12. The 3 is actually 2 cis. Instead of adding 2 pi over 3, I'm subtracting 2 pi over 3 from minus pi over 12. Okay? So this is going to be 2 cis, let's say, minus pi over 12. Subtract 8 pi over 12, if I'm not mistaken. And this is going to be 2c's. Minus 9 pi over 12, which is minus 3 pi over 4, okay? So the 3 complex number here are the cube roots, distinct cube roots of W. W, we just raise any one of them to the power 3 and write it in the Cartesian form. That's it. So what I'm doing here is I'll go back to my CAS calculator and do, all right, here is 2 times e to the power of I times minus pi over 12. So this is the first cube root, the1. And then I just make this answer to the power 3. And the answer is 4 root 2 minus 4 root 2i. So I'll write this down for our W value. Which means my A is 4 root 2 and B is just minus 4 root 2. So, ta-da, question 1 finished. Question 2, logistic equation and differential equations. In a certain region, 500 rare butterflies are released to maintain the species. It is believed that the region can support a maximum of 30,000 such butterflies. So this is the carrying capacity of the environment. And R release, that means at the beginning, T equals to 0, P equals to 500, okay? And P is the population of the butterfly, T years after the release, okay? Now for the first part, using an integration technique and partial fractions, solve the differential equation above to find P in terms of R and T. So instructions given, you have to use your calculus rather than DSolve, but we can also use DSolve to double check our answer. But firstly, what I'm trying to do is to make the right-hand side in a meaningful way. Let's say R times P times 30,000 minus P divided by 30,000, okay? Then you just separate the variables. For example, you can separate the variables by dividing everything by this chunk, multiply everything by dt, okay? So you're gonna get 30,000, P times 30,000, subtract P. Put a dp here, integration and integration R times dt, okay? Separate your variables. Now, this is just one integration technique, but I also need to use partial fractions, which means I'm going to decompose the left integrand into 2 pieces, something over P, something over 30,000 minus P. So what I'm doing here is go for my CAS calculator because that's the exam 2 question. Expand 30000 P times 30000 minus P. Variable is P. Well, the calculator will tell you a correct partial fraction form, but remember, because of the physical constraint, the population has to be less than, it's only approaching to, but always less than 30,000. That's why you need to write instead plus 1 over 30,000 minus P, okay? So when you are writing the partial fractions on your physical paper, write the second denominator in the reversed order, all right? And put a plus in front. Okay, now I'll jump back to my question again. Integrating R with respect to T will give you RT, okay? So now what I'm getting here is log EP don't need to put absolute value here because P is greater than or equal to 500 but less than 30,000. Okay, it's a positive quantity. No need to put absolute value if you are pretty sure it's a positive quantity. Minus log E 30,000 minus P plus C equals to RT. Okay, so this is the first part of the question. We're using separation of variables and partial fractions to find the general solution first in terms of P and T. And then we substitute the value. T equals to 0, P equals to 500. And then log E of 500 divided by 29500 plus C equals to 0. And if you cancel that out, C is minus log E. Well, better use my calculator to double check what the value should be. So 500 divided by 29500. This would be 1 over 59, okay? So 1 over 59, which means my C value is simply log E 59, okay? Because you just take the reciprocal, put in the negative index on 1 over 59, and that's the reciprocal. So with the C value here, I'm going to say, okay, the combined version RT equals to log E 59 times P divided by 30,000 minus P, okay? Okay, it's quite a bit of by hand work for a 3 marks question, but fortunately the question didn't stop us to use the calculator for P in terms of T. So I'm going to just button press again. So R times T, remember it's R times T, not RT on the calculator. Natural log 59P 30,000 minus P, comma P. Oh, comma. So the answer is 30,000 times e to the power of RT divided by e to the power RT plus 59, okay? So that is your solution. Function P as a function of T, okay? Just write that down. And then the next part carries on. The next part, given that after 10 years, there are 1,930 butterflies in the population, find the value of R corrected 2 decimal places. Basically, it follows on from the answer here, okay? If I want to find R, I can say given P equals to 1930 space and T equals to 10 years. Enter gives you the exact value, but we want it corrected 2 decimal places, which is 0.1400, okay? 0.14. So that's the second part. I will write that later. By the way, to double check if you get the correct answer or not, you can go for DSolve. Menu, let's say calculus, and differential equation solver. Let's say P dash equals to R times P times 1 minus P over 30000, close bracket. Independent variable is T, dependent variable is P. Condition is P of 0 equals to 500, okay? That's the initial population. So now, putting all together, this is the correct answer, okay? So using DSolve is trivializing that question, but you have to show some calculus, algebra, and the partial fractions. Also substitution. Okay, let's get back to the second part. So I'm going to say P equals to, for my calculator, This is the answer. Note, if you're writing the equation for R, you need to explicitly write R there rather than T, okay? In the past, I saw students confusing between the constant K, R, and the variable T, okay? So make sure you write down the correct letter. And R is 0.1400 something, which is approximately 0.14, 0.14, corrected 2 decimal places. Okay, next part. What is the initial rate of increase of the population correct to 1 decimal place? So the rate of change is actually given by dp dt equals to R times P times 1 minus P over 30,000. Notice that R equals to 0.1400, blah, blah, blah. This is a known value from this point on, from part B. Now, initially T equals to 0, corresponding to P equals to 500. So instead of finding, T equals to 0 and the derivative, I could just substitute P equals to 500 and the R value I obtained into the derivative here to find the rate of change. So I'm going to say R value is here. Okay, so R times P times 1 minus P over 30000, given that P equals to 500 and R equals to that. Notice I used all digits to make sure the accuracy is never compromised in the subsequent parts. So the rate of change is just 68.85, which is 68.9, I suppose, correct, 1 decimal place. And the unit is butterflies per month. Not per year, bear with me, per year, because the time is in years, okay? And the next part is asking how many years will the population reach 10,000 butterflies? Give your answer correct to 1 decimal place. So I'm going to use the solution here. So just copy this down, equals to 10000, comma T, given that R equals to that value. So it takes 24.168, so 24.2 years to reach 10,000 butterflies. Okay, let me just fill in the answers here. Okay, and finally, we only have part E here. Sketch the graph of P versus T on the axis below, showing the value of the vertical intercept. So basically, we know it's just each one grid is 1,000, so half of that grid will be 500. 0,500, okay? And the asymptote is the what's called maximum sort of population, but that's a upper bound, okay? It's not a turning point maximum. So I'm going to use my ruler here again. Draw an asymptote, okay? Very first thing, your easiest two things, the horizontal asymptote and your initial value, which is also your p-axis intercept, the vertical intercept. And now label the point of the fastest population growth. I know the fastest population growth happens when p equals to 15,000. Half of that, half of that maximum carrying capacity as a coordinate pair. So I need the point of inflection. T label corrected 2 decimal places. So now, remember we had already calculated the R value, and also we know we just replace the R with 0.1400356, etc. Okay, so I'm going to copy that into the next line and copy this value into here. Make this Tx and copy times x. Okay. Once I get this right-hand side expression ready, I will highlight everything. Control X and Control I. Add graphs. Remember, you have to closely adjust your window setting on the CAS calculator to closely match the grid paper provided on the exam booklet. This is a very common suggestion, which you should know. So menu, window zoom, window settings. X is T value, so 0 to 60. Let's say X scale is 10. Y minimum, let's say Y minimum is 0, maximum is 32000, slightly above 30,000. Okay. The Y scale, let's use 1,000, I suppose. Okay. Now everything should set up nicely, and I just press Control V. Remember, we copied that before. Okay. Okay, nice. So we have this nice logistic curve. So finally, I'm looking for the point of inflection here. Analyze graph, inflection, click left, drag it to the right. 29.118. If I want more decimal places, I could just hover my cursor until I see an open hand and open palm. Yep, pretty good. So I will be transcribing whatever I have. It's about 29.12, okay, 29.12. And the Y value or the P value is exactly 15,000. And you should be really careful. When T equals to 60, you are expecting you expect this Y value just right below 30,000 grid, okay? Grid line. So you need to be very careful when you do the graphing function. I know the assessors are marking the graph questions very carefully and closely. All details must be addressed and showing some good concavity, okay? So let's go back and show final graph. Some good concavity to be shown, and some good concavity to be shown, okay? Maybe I should just slightly adjust what I have here. Yep, something like that, all right? And double check if I answered everything. Asymptote, yep, I've got that. Point of inflection, yep, I've got that. Y-intercept or P-intercept, yep, I've got that, 0, 500, yep. And finally, corrected 2 decimal places, yet 29.12. Good. So we're good to move on. Vector planes in lines. A plane pi1 is described by the parametric equations xyz equals to blah, blah, blah. But remember, the algebraic structure xyz is just like a R here. If you see them as column matrix, the problem is very easy. So basically, it equals to 1 minus 2, 2, plus a letter S, one parameter is S, times 2 minus 1 minus 1, another column matrix to represent one direction, and then plus another t lots of 3 minus 2 t. Okay, so basically what the equation is telling you, what is that? If you think this one as one vector B, this one is one vector C, and this is your start point A here. Drawing the diagram, you have this point A here along this direction. This is B, this is C, and you can find a perpendicular vector to B and C, okay? And they're intersecting at point A. So that's how you define a plane here, which I'm shading in yellow, okay? All right, so the vector equation pi1, let's write it as R equals to 1i minus 2j plus 2k plus s lots of 2i minus 1j minus 1k plus t times 3i minus 2j. Actually, I transcribed this incorrectly. This will be 1, okay, rather than t, plus 1k, okay? Don't forget you need to mention s and t, they are any real numbers, okay? Not just positive real numbers or 0. Hence, find the Cartesian equation of the plane pi1. So, as I explained before, you need your normal vector. So how do I find a normal vector? Normal vector is basically B times C, okay? Cross multiply. And that gives you a vector. And also, we can use n1x plus n2y plus n3z equals to k with a common point between two lines, which is the foot of that perpendicular vector. Let's say 1 minus 2, 2, okay? So that's the structure of the part B. So what I'm doing here is I use my CAS calculator. Now it's another problem, so I'm going to control up, insert a problem, and add a calculator. Define, let's say A equals to 1 minus 2, 2. Define B equals to 2, minus 1, minus 1. Define C equals to 3, minus 2, 1. All right, now define N equals to cross P, cross product B, C. So N is minus 3, minus 5, minus 1. And then what I'm trying to do is another operation could be dot P x, y, z minus A, comma, N equals to 0. So this is how you use your CAS calculator to determine the Cartesian equation of the plane. We're using R minus A dot multiply normal vector N, whole thing equated to 0, because any difference vector within that plane is perpendicular to the normal, okay? And your reference point is this point, which is point A. So let me just shift back to my iPad. Minus 3i, minus 5j, minus 1k. So the equation will be minus 3x minus 5y minus z equals to k. Subbing the point, we get minus 3 plus 10 minus 2 equals to k. So k is going to be, let's say, 5 here. Therefore, pi 1 Cartesian equation is minus 3x minus 5y minus z equals to 5, okay? This form is perfectly acceptable in my opinion, because if you just multiply -1 to both sides, that's another equivalent answer, okay? As long as your constants are correct, you have x and y and z. Okay, now Cartesian equation for the pi 2. So a point E103 and parallel to the plane pi 1. This is parallel to the plane pi 1. They should have the same normal vector, okay? If they're parallel to each other, but now the reference point is different. So I'm going to use, okay, so my normal vector is still -3i, -5j, -1k, okay? But now I've got a reference point P here, which is 103. 1i plus 0j plus 3k. Let me double check. 103, correct. So I'm going to use r minus p instead of minus a multiplied by normal vector n equals to 0. This is a scalar quantity, scalar 0, okay? So now I'm using my calculator again. What I'm using is still the previous line, but now I'm no longer using a, I'm using p, which is 1, 0, 3. So now you should have minus 3x minus 5y minus z plus 6 equals to 0. All right, just jot down that answer. Should be fine. This is -6, okay? Because the right version gave you minus 3x minus 5y minus z plus 6 equals to 0. So this is my pi 2, okay? All right, next. Find the shortest distance between the planes pi 1 and pi 2. So, as I mentioned before in the multi-choice question, right. Now I just need to write down two equations in appropriate form. Pi 1 is actually, if I divide everything by -1, that will be 3x plus 5y plus z equals to -5. Pi 2 is going to be 3x plus 5y plus z equals to 6, okay? So you basically apply the similar idea to the multi-choice question before. All right, let me just cut this to the next page. With these two, if I draw x, y, z, this is O, okay? I would say pi 2 is here. Let me just highlight that in blue. You're gonna get shortest distance here, okay? From the origin to this point. So let's say D2. D2 is gonna be K over N magnitude, okay? So I'm going to use 6 over square root of 9 plus 25 plus 1, which is 6 over root 35, I suppose. Yep. And then d pi 1. This is pi 1. This is d1, okay? This is d2. So what I'm trying to say is d1 equals to k1. Actually, I should say k2, okay? k1, k2 to differentiate between them. Still, the magnitude of the normal vector, k1 is minus 5 over square root of 9 plus 25 plus 1, which is minus 5 over root 35. Don't forget, you are looking for the distance between two planes. One is a negative distance, another is a positive distance. So you put in the negative distance as a positive and add them up, okay? Otherwise, you use 6 over root 35 minus 5 over root 35. So the total distance, total shortest distance, is going to be 11 over root 35. Or if you wish, write that as 11 root 35 divided by 35, okay? Okay, simple as that. Now, have a look at this one. Hence, find the coordinate of point Q, which is the reflection of point P in the plane pi 1, as shown in the diagram above. Well, that phrase hence here implies you need to use the equidistant property. If point Q is a reflection of point P about pi 1, then I would say this is 11 root 35 over 35. This is also 11 root 35 over 35. But if you just look at the distances, that's too narrow. You should also think about, okay, what is the point here, M? Think about the point M and the relation between Q and P. What is that? A midpoint. Simple as that. So I will need to find the point M first. So M, let's say, if you just drew a line through Q and P, we know this is like a perpendicular line, right? And do we know point P? Yep, we know point P, the coordinates. 1, 0, 3. Okay, 1, 0, 3. That's it. And do we know the direction vector? Of course we know the direction vector, which is the normal vector, okay? We could use, let's say, now I'm going to use the positive version of the normal vector. Let's say n2 equals to 3, 5, 1. 3i plus 5j plus 1k, okay? So now, I'm writing down something above. The normal line to both pi 1 and pi 2 is given by r equals to 103 plus some sort of t, 3, 5 minus 1. So we have x equals to 1 plus 3t, y equals to 5t, and z equals to 3 minus t. What do they do? You can actually substitute the three equations into which one? Pi 1, to find the intersection between line and a plane, a line and a plane here, okay? A line and plane. So you basically say, okay, this is my pi 1. What is my pi 1? 3x plus 5y plus z equals to negative y. We should have 3 plus 9t plus 25t plus 3 minus t equals to negative 5. So basically I'm getting, let's say, 6 plus 33t equals to minus 5. 33t equals to minus 11, t equals to minus 1 over 3, okay? Not very big number or nasty number to work with. With the available t value, I'm going to find the point M. Okay, now I probably need to borrow my CAS calculator. So what I'm doing here is let's say 1, 0, 3 plus t times 3, 5, minus 1, given that t equals to minus 1 over 3. Okay, so I should have actually, bear with me. It should be a positive one, okay? Let me just double check. Yep, I wrote down something incorrect. So let me just go back and have a look, a further look. Yep, I copied down a round number here. It should be plus 1 here, plus t here. So what I'm getting is plus t here, and 34. Hang on a second. I'll take a further look. Yep. And I should have 35 instead of 33. Still manageable. Minus 11 over 35. Yep, that should be the correct value now. And then I substitute the value of t back. This is plus 1 here, okay? For the point M here, Rm is equal to 103 minus 11 over 35 times 351 instead of minus 1, okay? So what I'm getting is, let's have a look here. (103) minus 11 over 35 times 3, 5, 1. Okay, so I should have this point here, 2 over 35 minus 11 over 7, 94 over 35. So better write this down. But you always want to use coordinate pairs, okay? Or coordinate triples. Now we are in the 3D spaces. So now the final thing is, if I know the right point and the midpoint, I should say, okay, I don't know the point Q, okay? So let's say half times Q1, Q2, Q3. Add up the point P. What is my point P? Point P is 1, 0, 3 equals to the midpoint M. Q1, Q2, Q3. Yep, I should get 3 coordinates for that intended reflection point Q, okay? Which is minus 31 over 35, minus 22 over 7, and 83 over 35. So that's it. I'll finish off writing the last part of this question. Okay, now let me just transcribe what I had on the computer screen, okay? All right.